This is question 14 again. Like seriously, I only have 2 more multiple choice. I don't know why it has to crash when it did. It's so sad. Anyway, that's alright. Let's try again. So you need to work out the structure of Y. Now this is a mini version of what you're going to see a lot in year 12, which is an reaction pathway. So you have multiple reactions happening. You have to work out the final product. You want to start with identifying the type of reaction. The first molecule is an alkene. Now alkene undergo addition reaction. That is the main reaction of alkene. In this case, it's undergoing an addition reaction with H2O, which means that X, the product of this addition, is, I don't understand why it keeps doing that, it's alcohol. So let's think about what that alcohol is going to look like. I have CH3, CH. So one of the bonds in the double bond is going to break. So you have a single bond left. And one of the carbon is going to take the hydrogen, and this carbon is going to take the OH. It doesn't matter where you put these two groups because you get the same answer regardless. And this alcohol is going to undergo a reaction with CH3COOH, which is an acid. And you need to know that when you have a reaction between an alcohol and an acid, the product is an ester via a condensation reaction. So what actually happens when you have a condensation reaction is that the H from the alcohol and the OH from the acid links together and it forms water, which is why it's called condensation. You produce water out of the reactants, and whatever is left is going to link together. Now this is going to look massive, so, and quite annoying actually to write. Let's see what I can do this. I'm going to do the C double bond O. I'm going to move the CH3 to this side. This, alright, let's change the color again. This O is actually linked to this C. Therefore, we're going to write that O now. So that O is here. And then from that O, I have a CH that is linked to a CH2. So I'm combining the two hydrogen that is linked to a CH3, and that's this CH3 I'm going to move up here as a branch now. So this is the ester that's formed. You don't have to name this year, but if you are interested, it's called 1-methyl propyl ethanoate. Alright, let's find it. Which one looks good? I think this looks good. What do you think? Yeah, no, this looks good. Alright, these two are just wrong. Answer's B. Difficult question. Need to turn things. So practice drawing esters. Moving on to 15. In a particular chlorination. Now chlorination, don't feel alarmed. Chlorination just means react with chlorine. Also, you probably want to feel alarmed if you have chlorine present. It is a toxic gas. You have a single I need to stop my jokes. You have a single hydrogen atom from this that is replaced. So the question does tell you this is a substitution. Only one of it is replaced by one chlorine atom. More than one compound of this formula will be formed. So this is just a fancy way of asking you how many structural isomer these molecules has. I mean, they are very nice by providing this. Okay, so one of these hydrogens is going to be replaced by a chlorine atom. I can have it here, one hydrogen from here, one hydrogen from here, one hydrogen from here. But if I have a hydrogen being replaced in one of these 9 hydrogen atoms, the molecule looks virtually the same. So the first way is to have, I'm going to do skeletal actually. I really like to draw this because I used to call it. chicken feet. So that carbon is this carbon, and then you have CH2, CH3, and then 3 CH3 coming out. So you have a Cl for one of them. That's one way. It doesn't matter which one, it will give you the same molecule. So you only have one there. Now you can also have the Cl being here, or you have the Cl being here. So the number of different compounds that could be formed in this mono substitution, my computer does not know this is a word. You have 3. And that is it for the multiple choice sections.